Scientists like to make measurements, like this skull. If you were asked to measure the height of this skull, how would you do it? And what about this fruit fly culture vial? What tool might you choose to use to measure its height? Let's take that same culture vial and lay it on its side. This will make it a lot easier to make the measurement. Notice two lines are going to appear on the screen. Use those two lines and the ruler shown on the screen to make a measurement of the height of the culture vial. Here is a slightly different image of the same culture vial, along with a slightly different measuring tool. Go ahead and make another measurement of the height of the culture vial. Record this measurement in your notebook as well. Okay, one more time. Same culture vial, new measuring tool. Go ahead and measure the height of the culture vial one last time using the image of the wooden ruler shown on the screen and record your measurement in your notebook. Okay, so you've made three different measurements of the same object using three different measuring tools. But were all three measurements the same? If they weren't the same, why do you think that this was the case? Does it matter the type of measuring tool that you choose to use when you make a scientific measurement? So you've seen before in the previous three measurements that you just made that the type of measuring tool that you choose to use to make your measurement might actually make a difference. Notice on the screen that you can see three different rulers. The ruler on top is actually a meter stick. The two rulers down below are just simple dollar store rulers that I picked up at Target over the course of the past couple years. Now I've tried to take those three different measuring tools and line them up at their leftmost edge so that they were all measuring 0 at the same time point. You can see that marked with the red line. Now take a look at the three rulers. Are the three rulers measuring, say, 4 centimeters at exactly the same place? Should they be measuring 4 centimeters at exactly the same place? Does it make a difference if one or more of the rulers is not measuring 4 centimeters at a particular location? What does that mean for the measuring tool that you choose to use whenever you make a scientific measurement? When scientists choose to make measurements in the laboratory, they want to choose measuring tools that will give them the most accurate measurement as humanly possible. So for example, if they wanted to measure that culture vial, like we saw earlier, they might use a pair of calipers. Calipers are highly calibrated instruments that, in the case of this pair of calipers, allows us to make a measurement to the nearest 1/1000th of an inch. But what does it mean to be accurate? Well, in science, accuracy is often determined, or often defined, as how close or far a scientific measurement may be to the actual value or to an accepted value. So when you look at that pair of calipers, what we're trusting those calipers to be able to do is to make measurements, again, in the case of this pair of calipers, to the nearest 1/1000th of an inch. And we can trust that when we make that measurement is being made accurately. Let's take a look at how the calipers can be used to make a measurement. I went ahead and set the calipers to 6 inches. You can see that on the screen that the numbers on the metal piece of the caliper say 6, and on the dial or the gauge piece that the numbers read 0. Thus, what we are measuring with the calipers at this point is 6.000 inches. Okay, remember we're measuring in or to the nearest 1/1000th of an inch. Now if I zoom in on each part of the caliper, you're going to see that just the inside edge of that metal piece of the caliper is lined up at the mark on the wooden ruler. And if I do that again at the 6-inch mark, you can see pretty clearly that the calipers are measuring 6 inches. Thus, in the case of this particular ruler, we can trust that the ruler is measuring 6 inches accurately. How do we know that to be true? Well, if the caliper is a highly accurate, highly calibrated device that is being used to measure 6 inches, and indeed on the ruler we see that that measurement equals 6 inches, we can trust that the ruler as well is measuring 6 inches accurately. Okay, so we're almost done. Let's go back to the culture vial, but this time, rather than using a ruler or a meter stick to measure the height of that culture vial, let's use the calipers. So I've positioned the calipers in such a way that I can measure the height of the culture vial. And if we zoom in on the calipers, we're going to see that the numbers on the metal piece of the caliper are giving me a measurement that's just a little bit less than 4.1 inches. But how close to 4.1 inches are the calipers measuring the height of the culture vial. Well, if we zoom in over on the gauge, we're going to see, you'll have to avoid the glare for the time being, that we're making a measurement that is approximately 4.03, let's say about 6 inches. A much more accurate measurement can be made with the calipers than could be made with either of the rulers that we tried to use previously. So what is the take-home message from this activity? Well, first, I hope you realize that the tools that you choose to use to make your scientific measurements matter. And not all tools that you may choose to use are made equally. Scientists are striving to use tools that allow them to make the most accurate measurements possible. Remember, what does it mean to be accurate? Well, to be accurate means that you're making a measurement that is close to, hopefully very close to, an accepted value or the actual value. And I tried to show you that with the calipers and the ruler. When we set the calipers to 6 inches, we would expect that any measurement we make with the calipers will also be 6 inches. And indeed, in the case of that one ruler, we were able to measure 6 inches. But keep in mind, that might not always be the case. Okay? In addition, I want you to realize that when you looked at that caliper, that there was a moment at which I had to look at the gauge of that caliper and make a decision. Was it 0.35? Was it 0.36? Was it somewhere in between? Ultimately, I had to make a judgment call. And when I made that judgment call, I introduced uncertainty into my measurement. Whenever I introduce uncertainty into a measurement, I'm going to have a measurement that is not as accurate as I might like, but is going to be the measurement that is going to be as accurate as it possibly can be using the tool that I've chosen to use.